All right. So today we're doing section 9.3, volumes of prisms and cylinders. Again, prisms can be considered cubes. That's what I like to call them. But, sometimes in some math books they prefer to call them prisms. Okay? So what is the volume of a prism? So let's write that down first. Now the reason why we call them prisms is because it could be a square prism, which we call cube, or it can be a rectangular prism, which we call a rectangular prism. So the word prism actually encompasses two types, a square prism and a rectangular prism. But it doesn't really matter what you get, just can look something like this. Right, and it's going to have a length, a width, and a height. Or it can be more rectangular. Oops. But it's still going to have the same measurements, a length, a width, and a height. So the volume, and maybe you guys remember this, is just length times width times height. Very simple formula. A length times width times height. Now, of course, the h may not always be labeled in the place where I put the h. It might be on the left side. It might be in the middle line going straight up and down. They can place it in different places. They can rotate it around in different ways. Okay? That's kind of like the only thing that can kind of make it difficult is they can kind of move it around and make it look different. But for the most part, they're going to give you everything you need. Okay? You just got to be able to pick the right one. So we're going to do two examples of this, and then we'll move on to cylinders. Okay, and now we'll do two examples as well. But here we go. So any questions on this one? It's pretty easy formula to remember. So here we go. For example number one, what I'm going to ask is just to find the volume of each figure. To the nearest hundredth. So to the nearest hundredth place. That means two numbers after the decimal, right? Like 0.25, 0.38. So you always got to look at the thousandths place to see if it's going to round it up or not. So we're going to find the volume of each figure to the nearest hundredths. Of course, if necessary, like if the number is 26, then there you go, 26. But if it does have decimals after, then make sure you round it. All right, so let's, we're going to take a little bit of time here because we're going to have to draw stuff. So here's number one. Let me try this one. And this is 6 meters, 2 meters. This is the way they're kind of drawing it on your homework. I'll give you a little bit of time to draw that. They actually decided to put like some markings here to let you know that these are 90-degree angles. It's not necessary. They're just telling you, hey, look, it's a rectangle on the bottom, right? Meaning there's a rectangular prism. But not necessary, to be honest with you. All right, so we know that the volume for this is length times width times height. Sometimes the easiest one to identify might be height. What's my height? 2, right? Because you're looking for the lines that are going vertical, right? So I know my height's going to be 2. So I'm going to put a 3 parentheses here. I'm going to fill them in. All right. What's my length? You kind of can't get these wrong, right? But it would be 6. The 6 that they're referring to in terms of length and width, it could either be this one or this one. It doesn't matter. Because if you call the bottom one's length, then the other one will be width. Or if you call the other one length, the bottom one will be width. It doesn't matter. Okay? So it's going to be 6. That means that the other measurement has to be 6 as well. So this is 36 times 2, which is 72. And this would be meters cubed. That's it. That's all you have to do. Okay? So just get the measurements, put them in, multiply it out, write it with the correct units. Notice how this one I didn't have to round to the nearest hundredths, right? Because of the fact that it came out to a normal number. Okay? Not everything's going to work out like that. I think actually in most of these it should, though, looking at all the multiple choice options. But for most of them, I think it is going to come out to something like that. Let me give you one more, and then we'll move on. Like I said, these are not terribly difficult to do. Once you get the hang of them, they're pretty quick. So here's number 2. Let me try to draw it the way they have it here. And they labeled it 5 centimeters, 11 centimeters. None of this stuff is to scale, so. We'll give you a little bit of time to write that out. We know our volume is equal to length times width times height. So I'll put that right there. Remember, you can mentally rotate these things, okay, to make them make a little bit more sense. Or since you have a piece of paper, you can literally kind of like twist them around to make them look a little bit more normal. Obviously, we can't twist them this way, but you can twist them circular, just not 3-dimensionally. So you might have to use your head to try to think, how would this look if I rotated around? Again, since this is a cube or a prism, in our case, height usually is easiest to identify. Which one do you think is the height? 5 or 11? Think it's 5? To me, it's 11, but honestly, it doesn't matter. But to me, what I was thinking is I'll rotate it. So you see the little part where all the little right angles are? I'm going to put that flat on the ground. And when I put that flat on the ground, 11 is vertical, right? So that's me kind of just doing this in my head. But if you said 5, there's nothing wrong with that either. Okay? But to me, I'm going to rotate it so that part with the right angle notation, I'm going to rotate it so that it's flat on the ground. Right? Once it's flat on the ground, then the vertical line is my 11s. So this is going to be my height. But notice it doesn't matter which number I pick because I'm just going to multiply all of them. What are my length and width? 5 and 5. So even if I put 5, 11, 5 or 5, 5, 11, I'm still going to multiply everything by the same numbers. So 5 times 5 is 25. 25 times 11 is 275. So that's 275 cubic centimeters. So the whole front page is that. Okay, you guys can see right here. It's all just prisms. Okay, cubes or rectangular prisms. That's all. The back side, we're going to talk about cylinders. So let's talk about that. But before I do that, any questions on this one? And just, I think the most important part is get a calculator. So you don't have to worry about doing this by hand. So, all right. Here we go. So volume of a cylinder. Now cylinders can appear upright or sideways. It kind of depends on what they want to do. So it could look like this. Or it can look like this. It doesn't have to be a long cylinder, it can be a short one. But it's supposed to have a radius that they give you. Okay? And that's usually that line right there. Now remember, just like yesterday, with the sphere, if they give you a line that goes all the way across the circle, that's called the diameter. So then we got to cut it in half. Okay? So be aware that the diameter might be given, not a radius, so cut it in half and then use that as your radius. But usually if they're going to give you just a half a line, that's going to be your radius. Okay? Now the formula for this is going to be 1/3 pi r squared h. Actually, I'm wrong. It's not 1/3. It's pi r squared h. The 1/3 is when you're doing a triangular prism. So that's like a cylinder, but that's like pointy at the top. That'd be 1/3 pi r squared h. This is just pi r squared h. Okay? So r squared is, well, the radius squared. H is your height, so that would be right here. Okay, so the height of the cylinder, and then you're doing the radius as well. Again, if they give you the diameter, cut it in half, that gives you your R value. So what we're going to do, we're going to do two examples, one of each type. One of them, they're going to tell you just solve it in terms of a decimal, and then the other one, they're going to say write it in terms of pi. So let's do both. So there's going to be, I'll leave the formula there. Number 3, or example 3. Find the volume of the figure to the nearest 100. So find the volume of the figure to the nearest 100. For this one, I'm going to probably need you guys because I cannot do these types of problems without a calculator. So I'll depend on you guys to give me some information. I'm just going to draw one out like this. Okay, and I'm going to put 4 yards, and then right here, the little arrow, and it's going to say 2 yards. So I have a cylinder with a height of 4 yards and a radius of 2 yards. So according to definition, my formula is pi r squared h. Well, pi times r is 2, 2 squared. H is 4. I mean, I can do this by hand, but then I got to figure it out in hundreds, so I got to multiply pi. 2 squared is 4, 4 times 4 is 16, so 16 pi is my answer, but not the way they want it. That's 16 pi cubic yards. Now, if they just want you to write your answer, or maybe just do one example, we don't have to do two. If they just want you to write your answer in terms of pi, you're done. 16 pi. That's it. Okay? So if they, because there's going to be 4 problems at the very end that say leave your answers in terms of pi. Okay? So you just write 16 pi cubic yards and you're done. But I need the actual decimal answer. What is it? Say again, 50.2.
264. 2654.
2654. No, it's fine. Because the nearest hundredth, that means this 5 is going to have to move that to a 7. So that's 50.27 cubic yards. Okay? And that would be my answer. So remember, this answer is what they want according to my instructions. This answer is what they'll ask you or ask from you if they want it in terms of pi. Okay, just put 16 pi. All right, you don't have to multiply it. If they want it to the nearest hundredth, though, you are going to have to multiply. So I'll stop right there.